ChemVid. Today we're going to talk about the periodic table and the trends that you can find on the periodic table. This information is very important to you because you will be using it to explain many things that come up in the future. So this unit about periodic trends and how they work and why they work and all these different properties are a very important thing to put your effort into really understanding. So let's get started. Alright, so the first thing that you need to know are some definitions. Lustrous means shiny. Conductors mean they allow electricity and heat to flow through them easily. Semiconductors allow partial transmittance or partial transfer of heat and electricity, whereas insulators actually block electricity and heat from being transferred. So this, for instance, conductors are things like metal. Metal, if a pan is hot, it's going to let the heat flow quickly from it to your hand, and so therefore, it hurts when you touch it. Whereas a semiconductor only allows part of that heat to transfer, and insulators are things that stop it. For instance, like plastic. Plastic does not heat up very quickly, and it does not transfer heat very quickly, or electricity. Brittle means that it's easily broken. It can be strong, but brittle just means that it will break easily. Malleable means that you can shape it or mold it. And then inert means that it's non-reactive. It won't react with anything. Ductile means that you can pull the substance into thin wires, like metal is ductile. You've seen lots of metal wires before. And then tensile means that it can be stretched without breaking. Okay, so these different definitions, we are going to use them in order to describe different properties, so they're important to know. All right, next thing, the periodic table is it looks like this. The way that it is put together, you have your first two groups, and then the lanthanides and the actinides actually go in between the transition metals and group 2. So when you're looking at the periodic table, this is how they're supposed to work. And when we do electron configurations, this will make a lot more sense to you. However, it's really hard to write those down. So we usually abbreviate it like this. And you have done your periodic table, hopefully, and colored your very own, and know about the periodic table and what things are called. So let's move on to some trends. The first trend we're going to talk about is atomic radius. So atomic radius is how big an atom is. It's the distance from the nucleus to the outermost electron. And there are two different things that affect the atomic radius. When you make a cation or an anion, which is just another word for positive or negative ions. Ions are when you lose or gain electrons. And so if you gain an electron, you're going to become bigger. The atom is going to become bigger because there's an extra electron in it. And it'll push the electrons out, and so the size gets bigger. But a cation, or a positive ion, is when the electron is removed, and so therefore the electrons can get slightly closer to the nucleus, and you're smaller than the atom. So 3 different ways to look at atomic radius. First is the atom, what it normally looks like, and then if it becomes a positive or a negative ion, the size will change accordingly. Alright, so when you look at the periodic table, these trends are the trends that you learned about in, again and again, periodic trends. If you have not done that assignment yet, I would highly suggest doing that because it really goes into the detail of why these trends occur, and that why is going to be very important to you as you start doing more in-depth chemistry later on. So if you haven't done that already, I would make sure you do that, okay? All right, so atomic radius. As you go down the periodic table, the radius gets bigger, and as you go to the left, the radius gets larger. And the reason why is because of the nucleus. So as you move to the left on the periodic table, the number of protons decreases, which means the nuclear charge in the middle of the atom that pulls in the electrons is getting weaker, and so therefore the electrons actually move farther out. Okay? So the reason why electrons are, or the size is getting bigger, is because the nuclear charge is getting less as you move to the left on the periodic table. And the biggest atom is francium. Next, we have ionization energy. And ionization energy basically means how much energy it takes to remove an electron. So when you have an ion forms because an electron is removed from the orbital. And this is very important to us because this is how bonds form, and this is how you create reactions. So if you think about an atom, and the nucleus is the positive charge, and the electrons are the negative charge, they are holding on to one another. So the bigger you get, the easier it is to pull off an electron from the outside orbital because it's getting farther away from the nucleus. And vice versa. If you have a really small atom, the electron is closer to the nucleus, the positive charge, so therefore it's hard to get it to pull away. So as you can see, our trend, as you go to the right and as you go up on the periodic table, the ionization energy increases because the atoms are getting smaller and the nucleus can hold on to the electrons easier. So helium, it has the highest ionization energy. And then finally, electronegativity. Electronegativity is a wonderful thing because it's what attracts electrons. So think about an ion, and the ion is trying to steal an electron from another substance, right? Another atom, so that it can get a full octet. And so in this case, you want a very strong nuclear charge so that it can pull in another electron. And since electronegativity and ionization energy both deal with the electron to nucleus ratio or distance, they have the same trend. So as you go up and to the right, you're going to have a greater electronegativity. And fluorine has the greatest electronegativity because the noble gases do not have electronegativity. They have a perfect outer shell, and so they will not pull in electrons or form ions. So therefore, noble gases do not have electronegativity. All right, so just by looking at the periodic table, you can find out if an element is metallic or non-metallic. You can know about the ionization energy, the electronegativity, and the atomic radius. So knowing these trends are going to help you explain why things happen in the future, and they're very important to know now. All right. I would check out this song on YouTube. It's the Element song, and it's actually quite fun. They have a lot of different information for every element on the periodic table to the tune of the Can-Can. So if you want, you can check that out on YouTube. All right, so metals. Metals are shiny and lustrous. They conduct heat and electricity. They are ductile. They're solids at room temperature, except for mercury. Mercury is the only metal we know of that is liquid at room temperature. And that's why they use it in thermometers and other things, because it has those properties of a metal, but it behaves like a liquid at room temperature. Metals always form positive ions. They make ionic substances, which you guys will learn more about next unit, but they do make ionic substances. And they also react with oxygen to form base, like a base, acid and base. Okay, so metals are important, and they have a lot of fun characteristics, and we use them a lot. Alkali metals they have the same properties as regular metals, but because they are on the far left side of the periodic table, because they only have one valence electron that's so easy to rip off, they are actually very, very, very reactive. In fact, when you react them with water, they react very quickly. Okay? They also have lower melting points because they're very soft. They're not as hard as other metals, and so therefore they melt easily, and they have lower densities. Okay? So alkali metals are unique in that way. If you'd like to see a reaction of alkali metals, go to YouTube, type in alkali metals and water, and it's the video from Brainiacs. It's very interesting. They throw pieces of the alkali metals in there, and you get to see the reaction. They're quite large and quite amazing. Let's see. Okay, so transition metals. Some things you need to know about transition metals are that they have multiple charges because their valence electrons are more fluid, and because their electrons can move around, they have properties that allow them to bend and shape and be conductive and all of those different things. Another good thing about transition metals is that they are usually silver, but as you know, you have gold and copper, which have different colors. So most of them are silver, but you do have like your oddballs of gold and copper. Nonmetals are also very important. So nonmetals are the elements on the right side of the periodic table of that staircase we talked about. And they are poor conductors, low melting points. They can exist as all of the phases, and they actually make acids instead of bases. They are also very brittle. So as you can see, metals and nonmetals are pretty much opposites of one another. If one is conductive, the other is not conductive. So as you're trying to remember all the different properties of the periodic table, if you know what metals are and what metals do, you also know what nonmetals do because it's the opposite. The important nonmetals on the periodic table are halogens and noble gases. So halogens are important because in that group you have three different phases. Chlorine gas is a gas, bromine is a liquid, and iodine is a solid that actually sublimes and turns directly into gas. So that's kind of exciting, I think, anyway. It's very pretty. It's also what they use in hospital rooms to clean wounds. And in that case, it's mixed with other things, and that's why it's brown. Let's see. We have a yellow, a brown, and a purple color to these halogens, and they are all very toxic. The reason why iodine and bromine are used to clean wounds is because they kill bacteria very well. All right, so we use them in low doses to clean wounds and in surgery. But chlorine and bromine are also used in pools to keep them clean, and that's why they are toxic, and in high enough quantities they will kill you. But if you use them correctly, they will kill the bugs and disease that you want to get rid of. So pretty cool. Noble gases are awesome because they are basically unreactive. They do not react with anything because they have a full valence shell. They're monatomic, which means they like to be by themselves. They like to be one atom. They don't like to bond with other things. They don't like to bond to each other, anything like that. Whereas like diatomic molecules are they always have to be together. They always want to be in groups of two. So noble gases are unique because they just want to be by themselves. They are usually gases at room temperature, and because of those properties, they are used a lot in light and putting off beautiful different kinds of light. Yeah, So that's noble gases. And finally, we have metalloids. And the metalloids are the ones that are on that staircase, and they are somewhere in between, meaning that metalloids behave like metals and nonmetals. They have properties of both, okay? And so, like, for instance, silicon. Silicon is a metalloid, and it's used in computers a lot because it allows for conductivity of electricity, it allows for malleability, it allows for a lot of the wonderful things that metals do. But it also has some non-metal properties, like it doesn't heat up as fast, and when you put it in a computer, the computer won't overheat, but you can still allow it to transfer data. So metalloids are pretty cool, and they're used in a lot of different ways, and we'll go over that more later. All right, if you have any questions, let me know, and I hope you have a wonderful time learning about the periodic table.